In this video, we are going to briefly review scientific notation. So you've had scientific notation before in math class, but it's been a little while. We need to refresh our memory, make sure that everybody is on the same page with it. We also are going to review how to do calculations using scientific notation. So first off, scientific notation is used as shorthand for writing very small or very large numbers, where we would have a lot of zeros either before or after the decimal. One of the reasons why we need to spend a lot of time on scientific notation in chemistry is because of that mole number, that 6.02 times 10 to the 23rd number. We are not going to want to write out all of those zeros. So when we do our mole calculations, we're really going to have to be comfortable with scientific notation. So scientific notation is always written in the form of something times 10 to the something. So this number out in front, this coefficient, needs to be at least 1 but less than 10 in order to be considered legal scientific notation. And then our exponent can either be positive or negative, and it's going to be positive when we have values that are greater than 1, and the exponent will be negative when we have numbers less than 1. So like 0.0075, that would have a negative exponent, whereas something like 2 million is going to have a positive exponent. All right, so we're just going to do a little bit of review to refresh our memory. So our first number, we have 103,000. We want to write that in scientific notation. So if we put the decimal here, because that's where it would have been, we basically just keep moving the decimal until our number is at least 1 but less than 10. So if we stopped right now, it would be 103. So that's definitely greater than 10. So we have to keep going, and we end up with 1.03 as my coefficient. So 1.03 is greater than 1 but less than 10. Now, in order to get my exponent, I see how many spots I moved it. Moved the decimal. So if we count, we moved the decimal 5. So it's going to be 1.03 times 10 to the 5th. We know that our exponent is positive because our number, 103,000, is definitely greater than 1. All right, if we take a look at number 2 is reverse. So I have the scientific notation. I need to turn it into the number. So 2 times 10 to the 6. So basically I'm going to take 2 and move the decimal 6 spots. Now, since my exponent is positive, I need to end up with a number greater than 1. So therefore, I would need to move the decimal to my right-hand side, because that would give me something greater than 1. So 1, 2, 3, 4, 5, 6. Then you go back and you add in 0. So it's going to be a 2 with 6 zeros. So that is going to be 2 million. And hopefully you remember doing this, back in junior high math class. All right, number 3, we got to turn that into scientific notation. So we have 0.6842. So we're actually almost there. We're almost to at least 1 but less than 10. If I move this over 1 spot, I get 6.842. That is at least 1 but less than 10. So that's going to be my coefficient. I only moved my decimal 1 spot. So negative 1 is going to be my exponent. Negative because it's less than 1. So and I only moved it 1 spot. So negative 1 is my exponent. All right, last one, 8.56 times 10 to the negative 4th. So I'm going to move my decimal 4 spots. Now, since it's negative 4, I know my final answer has to be less than 1. So this is going to go 1, 2, 3, 4. So I'm going to fill in 3 zeros, 8, 5, 6. So I'm less than 1 because of the negative exponent. So therefore, I moved the decimal over to the left-hand side. Right, now we just have to review how to do calculations that involve scientific notation. Now, yes, a lot of times you can plug these into your calculator, but sometimes you can't. And also, you need to know if your answers make sense too. So, when we add and subtract with scientific notation, it's a little bit of a pain because we have to change the exponents into each other. So they need to have the same exponent. Now, technically, you can change either one, but it's going to save you a step at the end if you change the smaller into the larger one. So what I mean by that is we have 2.7 times 10 to the third, 3.2 times 10 to the second. So what you're going to do is you're going to change the smaller into the larger. So we're going to change that into 10 to the third. But we also have to adjust the coefficient because if I just up that to 10 to the third, I'm going to be increasing it by a factor of 10. So then we also have to make this smaller by a factor of 1 since I increased the exponent by 1. If you had increased the exponent by 2, you would make your coefficient smaller by 2 decimal places. So 0.32 times 10 to the third. Now I realize that that's not proper scientific notation, but it's not our final answer, so that doesn't matter. But these would be equivalent numbers. They both are 320. Once you've done that, then you add if you're adding or subtract if you're subtracting your non-exponents, so your coefficients. So we do 2.7 plus 0.32, so that would be 3.02. And then you keep the exponent times 10 to the third. Oops, that's a little messy. That's supposed to be 10 to the third. Then we just round for a significant figure. So you look at the original numbers we're adding. So we do decimal places. So 3.0 times 10 to the third would be our answer. So that would be 3,000. Subtraction, same idea. We want to make their exponents equivalent. So we're going to change the smaller into the larger. So this is going to become 10 to the 21st and 0.758 for the coefficient. Again, since I upped the exponent by 1, I have to decrease the coefficient by 1 place. Then I'm going to subtract. I'm going to end up with a negative number, and that's perfectly fine. So 0.758 minus 6.2 is going to give me negative 5.442. And then my exponent's going to stay 10 to the 21st. So then I just need to round this. So that is now going to be negative 5.4 times 10 to the 21st. All right, most of the time we will be multiplying and dividing. So when we multiply or divide, we don't have to make the exponents equal first. So all you do is you multiply your coefficients if you're multiplying, or divide your coefficients if you were dividing. So we have 7.2 times 3.4. That gives us 24.48 for my coefficient. And then if I'm multiplying, I'm going to add my exponents. So negative 2 plus 4 would give me 2, 10 to the second. Now I need to make this legal and have the right number of significant figures. By make it legal, your coefficient should be between, or at least 1, but less than 10. So 2.448. Now, since I decreased my coefficient, I have to up my exponent to maintain the same value. And then lastly, I need to round for significant figures. So I only want 2 significant figures. So 2.4 times 10 to the third would be my answer. All right, in my division, 7.5 divided by 2.5, so that's easy. That's going to be 3. And then I'm going to, since I'm dividing, I will be subtracting my exponents. So that's going to give me an exponent of 4. I'm already between 1 and 10, so I don't have to worry about that. But I do need significant figures, so 3.0 times 10 to the 4th would be my answer.